Today we are learning how to obtain flash figures for biaxial minerals. We use the flash figure to find a grain useful for characterizing minerals along their principal axes. This will tell us how our mineral grain is oriented. For biaxial minerals, all three principal axes are different. We label our principal axes as alpha, beta, and gamma. For biaxial minerals, alpha always has the smallest index of refraction, and gamma always has the largest index of refraction. The index in between is beta. When we are looking at a grain in the microscope, we are looking at a slice of the ellipsoid. For biaxial minerals, finding a flash figure lets us know that we are looking at a slice that looks down at an alpha-gamma section. This is the green ellipse in the figure. Alpha will always be the fastest ray, and gamma will always be the slowest ray. Now, let's go through the steps to acquire a flash figure. Step 1. With the cross-polarized lens in place, find a grain of a chosen mineral that exhibits particularly high retardation and interference colors. Step 2. Switch to the highest magnification and focus. Step 3. Switch on the Bertrand lens and the condensing lens. On this microscope, the switch labeled BL above the cross-polarizer switch inserts both. Step 4. As you slowly rotate the stage, your figure should become extinct and then illuminate itself, similar to a uniaxial flash figure. Here, I am only rotating the stage by very little, only a couple of degrees. You may be able to see a faint, thick cross appear and disappear as you rotate your stage. This is unique to biaxial minerals. Next, I take out my condensing lens and Bertrand lens and switch to a lower objective. Focusing on the same grain, I perform a fast and slow ray determination. Inserting my accessory plate from the southeast, I notice that in this direction I am looking at the slow ray, and in this direction, I am looking at the fast ray. Therefore, in this direction, I am looking along gamma, and in this direction, I am looking along alpha. Now, I turn my stage and go back to gamma. In order to align gamma with the lower polarizer, I rotate my stage 45 degrees counterclockwise to the extinction position. Then, I take out my accessory plate and my cross-polarizer, and without moving the stage, I can characterize my grain along gamma in plain polarized light. Here, it is colorless with medium relief. Next, I put my cross-polarizer in and rotate another 90 degrees counterclockwise to the next extinction position. This aligns alpha with the lower polarizer. Again, without moving the stage, I can observe color and relief in plain polarized light. Along alpha, our grain is colorless with medium relief. In this mineral, the difference between alpha and gamma is small and may be difficult to distinguish. Other minerals show much greater differences in color and relief between alpha and gamma. For an example where this is relevant, watch the linked video on how to fully characterize a mineral grain. In this example, I also go over how to characterize along beta. Here are some things to remember and some helpful tips. When picking out a grain to obtain a biaxial flash figure, look for the grain exhibiting the highest retardation and interference colors. The flash figure lets us know that we picked a good grain for characterization along alpha and gamma. Alpha and gamma never change, unlike uniaxial minerals. Alpha is always the fast ray and gamma is always the slow ray.